Today we have a guest presenter, Ben Chung, who is an engineer for Nokia, and he will be talking with us about artificial intelligence and what it is from a more techie perspective. Ben is also a friend, and we do a lot together, and so I wanted to pass the floor over to Ben.
Hey, thank you. So I'm very honored to be here to be able to give you some insights into artificial intelligence. Um, First, a little bit about my background. Currently, I work on as a division of Bell Labs, working in ORAN standards with 5G cloudification and orchestration, working on the next generation of wireless technology. Pretty soon, probably by the end of 2023, I'll be starting to work on 6G stuff. I've worked in 26 years in the wireless industry, starting with 2G, TDMA, and then 3G UMTS and 4G LTE, and now 5G. I started working at Lucent Technologies, and that merged with Alcatel-Lucent, and then now Nokia. I was a software developer, system engineer, and architect. Before that, I was working at General Electric Medical Systems, working on ultrasound and MRI systems. I have a few patents under my belt, and I have a master's in electrical engineering and a PhD in operations research. I've been to 30 countries on 6 continents, soon to be 31. And next February, I'm going to Prague in the Czech Republic. And I've written 6 books, the latest of which are The 4 Elements of Thinking and The Periodic Table of Ideas. And I've designed a number of games and was the former HeroClix world champion.
You'll have to
Okay.
go to see the Golem when you're in Prague.
Yeah, right. I'm just starting to take a look and see what's there, what's interesting there to see. Okay, so my talk is kind of broken into 4 parts. I'm gonna uh, go over some of the big ideas in artificial intelligence, and that's probably if there's any takeaway I'd like you to have, it's probably that first section that I'm gonna go over. And then I'll go over some timeline information, how AI and ML have developed, maybe a little bit about where it might be going, and some of its history, and then some of its applications, how it's used, and who are the players. So in this first section, I'm going to talk about some of the most important ideas and from a technical standpoint on artificial intelligence. But first, maybe let's take a little bit of a stab at what we mean when we talk about intelligence. And it's a hard and somewhat elusive thing, I think, to define, and somewhat relative as well. So, but in a good book I'd recommend, just a simple, easy read, is a book called AI for Dummies, which is where I got this list from. They define intelligence as these 7 basic concepts. 1, learning, the ability to obtain and process new information; reasoning, the ability to manipulate information; understanding, considering the results of that manipulation; comprehension, grasping truths and determining the validity of manipulated information; seeing relationships and divining how validated data interacts with other data; considering meanings, so the ability to apply truths to situations in a manner consistent with their relationship; and separating fact from belief, determining if the data is supported by provable sources that can be demonstrated to be consistently valid. So that's probably a decent characterization of intelligence. Some of the things that might come to mind are like, hey, where's creativity, and that sort of thing. But this focuses sort of on the ability to think and reason, and some of the things that make thinking unique. From a different aspect, there's another way to look at it, and that is to look at sort of different aspects or characteristics of thinking in these other 7 intelligences from Martin Gardner. One, the visual spatial, the physical environment that people like sailors and architects use to be able to interact and sort of visualize your environment. Bodily kinesthetic intelligence, where like a surgeon or dancer can have a good what's called proprioception, the ability to sense where your body is and have body awareness. Creativity is the act of developing something new, basically, and unique in the form of art, music, or writing. And these are new kinds of products that result from creativity. So interpersonal intelligence, the ability to interact with others at different levels, it the ability to obtain and exchange and manipulate information, which we saw in some of the previous definitions on the previous slide there. Intrapersonal intelligence, the ability to look inward and understand your own interests and setting goals based on those interests, is a kind of human intelligence. Linguistic intelligence, the ability to work with words, and which is essential for communication, both spoken and written. And they differentiate between spoken and written parts of the brain, like the Broca's area, right? The ability to take in input and understand language, and to be able to form a cogent answer and to formulate intelligent speech. And then finally, the logical and mathematical, the calculating aspect of the brain, be able to perform comparisons, explore patterns, and consider relationships. So these two kind of background slides just get you to think a little bit more about what does it mean when we say something is intelligent, right? And that intelligent part of artificial intelligence. What does it mean when we're trying to achieve uh, the before that the before we achieve artificial intelligence? What is actually non-artificial intelligence, right? So artificial intelligence, when you hear it nowadays in 2023, is closely associated with machine learning and deep learning. But 20 some years from now, it won't be, right? So I think right now, machine learning is such a successful paradigm of how we're essentially emulating, or at least moving towards true artificial intelligence, that the two are seen together a lot. So um, I think it's very important at this stage to learn what these things are. So artificial intelligence is the ability of machines to simulate human behavior and make intelligent decisions. Machine learning is the ability to learn through experience without being explicitly programmed. And deep learning uses artificial neural networks capable of adapting, learning, and making intelligent decisions. So these three parts of different aspects of how to learn and how to uh, grow and use experience is part and parcel to what we would think of, I think, as artificial intelligence at right now. So really, really key fundamental idea. This slide is really important. So the next few following slides, if you take nothing else from the class, I think these are the things that you should walk away with and remember. So there's different major areas of artificial intelligence. So we talked about artificial intelligence, machine learning, and deep learning, but there's also predictive and analytics is sort of a pre-step before artificial intelligence. It's basically predicting future outcomes using historical data and statistical modeling. So it was kind of sort of what the area of study before artificial intelligence really became more prominent. Being able to apply statistical methods was sort of the foundation of some of the early inroads into artificial intelligence. And then neural networks is another major area, connecting elements and processes of the data that can adapt and learn from past patterns. So artificial neural networks and convolutional neural networks are also really part and parcel of artificial intelligence. And it's really the it's nothing new. So the study of the neuron, because is many decades old, and the first attempts were really in software, at least, were to create artificial neural networks to emulate what a neuron in the brain does, hoping to sort of because we don't really yet know what maybe consciousness is to sort of emulate that just through emergent behavior and emergent properties. So the future stages of artificial intelligence, right now we have what's called artificial narrow intelligence or so-called weak AI. And some examples of those are like expert systems, which were popular in the 1980s and 1990s, very algorithmic. And the concept there is to basically emulate an expert at something. So, without having just the general uh, intelligence, maybe we can sort of emulate an expert at doing something. You give it some input, and maybe it can read an X-ray or give you some advice of a movie you might like, that kind of thing, somebody who's an expert at something. Data mining and pattern recognition. So we're in that phase now. You see lots of methods and techniques for AI now that involves basically things related to machine learning and deep learning to be able to mine and find patterns in data. Human-computer partnerships, we're just kind of at the beginning of that now. I think you'll see much more human-computer partnerships before we fully see artificial general intelligence. And even then, I think you'll still see a lot of human-computer partnerships in really every aspect of our lives and industry and our economy. So a simple example of that is whenever you drive a car using a GPS, that's a human-computer partnership where your computer is helping you in some way to do something better. But we'll see that in future slides. But another example might be a pianist who wants to create a new piano piece or a new piece of music. A computer can help them develop music with the human steering and with the major vision, but the computer is doing some of the crunching number work. Navigation systems are obviously something that's very pervasive and very evolved now. So, the GPS systems and uh, the ability to pinpoint something will be mixed with things like IoT, the Internet of Things, as well as 5G. One of the key ideas in 5G wireless right now is uh, called MMTC, Massive Machine Type Communications, where basically uh, machines are talking to machines, and the ability to navigate to places is we'll see is important. Also, has already played an important role in our society. Um, the next stage after that will be general artificial intelligence, where the so-called strong AI, the ability for computers to recognize, to learn, to see and process language, and then strong AI with a transcendent ability, artificial superintelligence, the ability to create and innovate, to decide, to plan and forecast, and advanced robotics and communications will characterize that next stage of AI.
Ben, can you give an
Yeah,
example of each of those?
sure. So a really good way to picture artificial general intelligence is um, the I'll illustrate it with with somebody who an example of say a doctor. So a doctor has in our society has sort of narrow. Very specialized intelligence to be able to heal somebody, to be able to apply the medical arts and techniques. Um, but yet that same person is able to follow the instructions to bake a cake, right? So that ability to ride a bike or walk down the street um, may seem very trivial and simple to us, but it's a characteristic of just very general intelligence. So the ability to apply intelligence very broadly, not just to a specific task, but to be able to recognize things, to have, say, a robot incorporated into AI incorporated into a robot, for it to be able to see and experience the world around it. A self-driving car would be could utilize artificial intelligence or a robot that sort of has the ability to interact with its environment and to be able to think broadly, I think is an example of that. Artificial superintelligence. Um, right now, of course, machines don't have dreams. They don't have desires. They don't have a consciousness or a will, right? And those things that we right now very we associate with maybe a soul or something very deeply human. I think will be characterized artificial superintelligence, and at that point, you sort of open up a lot of certainly from a legal, but many other standpoints as well, sort of a what you start asking, what is life, and have we created a robot that's alive, and that sort of thing. When you start asking those sorts of things, when you cross what's called the singularity, I think that kind of characterizes artificial superintelligence. So, think of a robot that has its own dreams that wants to, I want to be a sailor or whatever. So,
Like Data from Star Trek.
like Data from Star Trek is a very good example. Yeah. So,
Yeah, and
okay.
yeah, I mean, we're already seeing a little bit of people trying to do this right now with that Google engineer who thought that one chatbot was uh what's what I'm looking for.
Alive.
Alive. That's what I'm
Yeah,
looking for.
yeah, yeah. No, absolutely. I think this won't necessarily be a smooth, linear, uh, suddenly you'll have no artificial intelligence, suddenly you will, or, there won't necessarily be a clear demarcation to, suddenly there's, yesterday there was no artificial super intelligence, and today there is. Um, but I think you'll probably see threads of these things developing slowly. So even in the areas of artificial general intelligence, you see aspects of computers recognizing their environment, the ability for them to learn, machine vision, and language. A lot of those things we already see in a lot of our things today, but we'll see more of those, I think, when we come to our AI that's able to generally think and broadly think. Yeah, good questions. Okay, so in the area of machine learning, again, machine learning is really kind of a method of a stepping stone towards how we achieve artificial intelligence. But it's such a successful mechanism, a successful paradigm right now that it's really core to artificial intelligence right now, and partly because of our computing power and our computing technology, which has followed Moore's law, since the 1960s. Gordon Moore from Intel sort of created this uh, sort of law, quote unquote, in air quotes, that computing power would double every 18 months. But that's, he kind of predicted that, but it's been true for many, for decades now. And so computing power has increased dramatically in the past few decades. And so the ability to just process information and use uh, raw data and find patterns in data has been very successful and is promising as a foundation for a lot of intelligent applications. So, and it's characterized by machine learning is characterized by three things: unsupervised learning, supervised learning, and reinforcement learning. So, in unsupervised learning, the computer is trying to find hidden patterns and groupings without necessarily having some sort of target. It's just simply looking for uh, information that is related to each other. So clustering unlabeled data sets, dimensionality reduction, clustering, and big data visualization. It's just looking for those trends and patterns without necessarily somebody saying, look for this particular pattern, right? So um, whereas supervised learning, I have labeled data sets and training algorithms and a task to predict values. So I'm trying to classify data or regression forecast and prediction. So an example of supervised learning might be I'm looking for a tumor in an X-ray, or a CAT scan or an MRI scan. I'm looking for a picture of a cat in a photo. Somebody says this is a cat. Well, if you're looking for a cat, I know what a cat looks like. This is a cat, and and the computer is supervised by something, by a target to look for. Whereas in unsupervised learning, I may be looking for, I've got my product out there in the market, and how's it doing? Is it, I want to find some patterns, or I want to find some patterns in the market, or developments in politics. So what are some general trends that I don't necessarily see? I want to find the pattern, and you're trying to find patterns in data. Reinforcement learning um, is used in real-time decisions, skill acquisition, and learning tasks. It takes input data, correct output data, and it learns from its mistakes. So reinforcement learning uses feedback in order to improve algorithms and improve the way that it's doing something. So we use this all the time when we learn any kind of skill. If you want to learn tennis, you use reinforcement learning. Somebody tells you this is how you perform a stroke and this is how you serve, and that sort of thing. So a good cartoon here for the difference between supervised learning and unsupervised learning. Here we have on the left here we have a something training an AI to recognize a particular thing in a photograph. Like the AI says, "Is this a banana?" And the supervised against it's looking at a target data set, a picture of a an apple, and the computer incorrectly guesses banana, and the um, the thing that it's comparing to says no, and when it says it's an apple, it says yes. So we'll see there in the fourth section, we'll see some examples of that, which is interesting. So being able to see images in photographs is something that's very easy for a human to do, but extremely hard. We found as the development of AI progressed for a computer to do. Here an example of on the right on the unsupervised learning. We see the AI analyzing a photograph of apples and bananas, and it notices that, hey, look, these three things, even though they're rotated, we instantly see that that's a banana that's rotated. One's upside down, and one's not, or one that has linear rotation, and the apple that might be rotated in some degrees, but it's the same thing. We instantly recognize that that's an apple. But in unsupervised learning, the idea is that it finds patterns, like, oh, those are two different kinds of things. It doesn't necessarily know it's fruit, but it's two different kinds of things. Again, very easy for humans to do, but kind of difficult for AI to do. Okay. So this slide here is just meant to show you that there has been really decades of work on artificial intelligence with lots and lots and lots of algorithms that already exist and methods and ideas that exist. Um, I don't expect you to memorize this or anything. It's just merely to show that there's a rich history of a lot of um, researchers that have used lots of interesting ideas to to try to advance the art of artificial intelligence. So I've mentioned like deep learning and neural networks, and there's regression methods, and some of the earlier things were like Bayesian methods. I'll talk a little bit more about that later. Simple decision trees to make decisions, and utilizing other ways to make a complex problem less complex, let's say. Um, but again, I just want to also illustrate it's very easy to get lost in the weeds, right? And the reason why I've structured the talk in this way is that when you work from the big picture, you see that you know machine learning and deep learning is really a means of being able to process a tremendous amount of data in order to try to achieve artificial intelligence, basically intelligence like things for decisions or to be able to identify images or to understand an environment or understand language. Okay, so that's the end of the first section. And again, that first section I think is really important to just understand what are some of the key concepts behind AI. If you don't walk away with anything else, I think the big ideas in AI is probably the most important section. Next, we'll talk about what are the key milestones in AI and some of its history. And we'll talk briefly about AI winters and maybe a little bit about the future of AI. So in 1950, Alan Turing proposed something called the Turing test as a measure of uh, machine intelligence. And that really kind of gets at what it means to be human. In the Turing test, you have a person, let's say, interacting with two people behind a screen. And if the person can't tell the difference between a real person and a machine, that would be a test to be able to tell if something was intelligence, Alan Turing said. So, if you're talking to two people, person A and person B, and you can't tell if one's a machine or not, then doesn't matter. That's something he said is intelligent. That would be a mark of intelligence. In 1956, John McCarthy coined the term artificial intelligence at the Dartmouth College Summer of AI Conference. So a lot of brilliant minds got together. Big names like Marvin Minsky and Claude Shannon, the father of information theory, Herbert Simon, and so forth were together, and the term artificial intelligence was coined. In the 1960s, Ray Solomonoff laid the foundations of a mathematical theory of AI, introducing universal Bayesian methods for inductive inference and prediction. Bayesian methods are introduced for probabilistic inference in machine learning. So given that you know some evidence or certain events that have happened before, can you infer inductively, can you infer that these next events will happen? So just because the sun rose yesterday, will it rise tomorrow? Or given that I saw these instances of these kinds of evidence of pollution, can I make some inferences about that? Given prior knowledge and prior history of something, can I infer something else? So that's kind of the basic idea behind Bayesian methods. And we've had a number of what were called AI winters, two AI winters, one that was between 1974 and 1980. And basically there was a huge amount of interest in AI in the 1950s. This is also couched in the history of the space race. We were very optimistic about our technology and our science. We just, in 1969 in July, we landed on the moon. And so we were all looking towards the space age, and we thought that AI would be really like the Jetsons would be here tomorrow, But when computing power really just wasn't there, the field is really in its infancy, and the people who had poured in a lot of resources into the development of AI weren't seeing the returns that they wanted, right? So they lost interest, and that characterizes an AI winter, what was called later to be called an AI winter. And so that was the first AI winter up to the 80s. In 1980s, the use of backpropagation algorithms caused a resurgence in machine learning research. Really, basically, the idea of feedback. So taking data and feeding it backpropagating it back into the input steps is the idea, and that was pretty promising. And we still use that fundamental concept today, just in other ways. In recurrent neural networks, for example. So the ability to take input uh, and 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 uh, take output and feed it back as input was magical, and that concept of feedback is really important. But then we had another AI winter from 1987 to 1994. The government and had poured in around the world, a lot of governments had poured in a lot of money into AI, and again, wasn't seeing the returns, and so we sort of people lost interest. But then slowly now, as the decades roll on, computing power continues to improve every 18 months. It's doubling, and so our ability to process and data is quite astounding. But come uh, come the turn of the millennia here. So in the 1990s, we shift from data-driven knowledge for a knowledge-driven approach to a data-driven approach. So support vector machines and recurrent neural networks become popular. I mentioned neural networks before. So basically, where in software you simulate a neuron, and those neurons essentially affect other neurons. So that's essentially how your brain works, right? So you have a neuron that its outputs, when it's stimulated, it stimulates other neurons, and those fire. Um, and that idea of using that with feedback, the back propagation, taking the outputs of what you're learning and feeding it back into the network to train a network so it can self-learn is a really central and crucial idea in modern AI methods. So in the 90s, we're still using a lot of those methods developed in the 90s, just applied with a lot more computing power. In 1997, the computer Deep Blue, which was a chess machine from IBM, defeated the then world chess champion Garry Kasparov, and that really made huge headlines when it was developed. In the 50s, it was thought, if you could develop, a machine that could play chess, that's got to be intelligent, right? And to some degree, it is. I mean, but we've come to learn that, chess you can apply a lot of algorithms to, and you can work backwards from certain board states to future ones. That it's maybe not as hard as we thought. And if anything we learned in the 1990s, and that is things that we thought were simple are actually really hard. So um, our ability to just walk across a room is we just that's trivial for us. But actually, computer vision, being able to differentiate objects and navigate through a room turns out to be quite challenging. um, Being able to interpret language in a noisy environment is extremely hard, and something we do trivially, right? So, um, the focus you'll see in the coming decades has been on just finding out that those things that were relatively simple for a human to do are we're starting to make inroads to in the coming decades. So in 2002, iBot's Roomba is an autonomous robot that vacuums the floor while navigating and avoiding obstacles. We still have a Roomba today. You'll still see that product is still in existence, and it's getting smarter and smarter. So I just saw a Roomba-like product that's able to more intelligently see some of the things that it's um, trying to vacuum. So in 2005, Honda's Asimo robot was an artificially intelligent humanoid robot. It can walk as fast as a human, delivering trays to customers in restaurant settings. And we see just in the coming decades up to now, up to 2022, there have been really great strides and great improvements in humanoid robots. The book I wrote on robotics had Asimo as one of its uh, on the cover actually. So it was, it was right around then. I was writing and studying a lot about robotics. In the 2010s, deep learning becomes feasible, which leads machine learning to become integral to many widely used applications and software services and applications. So deep learning is really crucial to our recent success with inroads into artificial intelligence. Um, 2011, Amazon introduces Echo, a voice-controlled intelligent personal assistant, and I think one of the really, I think, important thing with Echo is that it introduces essentially artificial intelligence to us in a way that's not like a robot. So we have we have in our minds that an intelligent thing has to look like a person, right? But actually, much more likely is something that AI will be able to help us in ways that doesn't look like a person. Um, And that's what I think uh, the major innovation with the Echo is. Here's the cylinder that it can listen to you and respond. Um, that is really, I think, how a physical form of AI will partner with us for a long time to come. Um, your smartphone is essentially just a slab. It's just essentially a rectangle, right? And but yet you can access the internet, the entire body of human knowledge in milliseconds, and with the right software, you can have it advise you on things or partner with you on intelligent activities that computer human partnership that we've talked about earlier. So the partnership on artificial intelligence to benefit people in society formed for the responsible use of AI, researches best practices for artificial intelligence systems, and to educate the public about AI was formed in 2016, a really crucial uh, milestone where as we before we develop general artificial intelligence, and certainly, hopefully, long before we develop super intelligence, that we've thought about uh, the all of those sort of legal and ethical and other crucial ramifications of AI uh, before we reach that singularity point. I think it's important. In 2018, Hiroshi Ishiguro created Erica, the world's first robotic humanoid news anchor in Japan. Um, so that's quite interesting. Um, and last year in 2022, these were sort of some predictions of where we thought the AI would make strides in. So an AI workforce augmentation, robots that assisted humans in mundane, repetitive work, partnering with humans. We still see that today, and that will be ongoing easily for the next 10, 20 years. Better language modeling. OpenAI's GPT-3 is the most advanced language model ever created with 175 billion parameters. And we'll see some examples of this. The use of GPT-3 is really, really impressive. And the metaverse, a unified, persistent digital environment, virtual world where users work and play together. For those gamers, if you've heard of an MMO RPG, massive multi-user online role-playing game, this is nothing special, right? The starting with Eve, EverQuest, and all those online games, they've already created persistent digital environments and virtual worlds, but making this a little bit more general, sort of like Second Life, where people can explore together, like a virtual Facebook, basically. So, and then autonomous self-driving cars. A lot of companies are working on self-driving cars: Google, Apple, GM, Ford, and Tesla. And we'll see that more of those developments in the coming decades for sure. And here I put together a slide of, again, maybe this is definitely speculative. So, um, the evolution of AI from enhanced narrow AI, the AI capable of doing more than one task, but each task designed to perform specialized functions. At 2030, AI initiated operations, AI software and mathematical solutions, and AI that can write research papers or that can create art, that solves and math problems and in efficient ways. And 2040 general AI, so AI with the full cognitive capabilities that mimic a human, and then maybe by 2060, super intelligent AI that is really almost indistinguishable from a human, that maybe it's alive or maybe that's achieved consciousness. So, but take these dates with a grain of salt. They are in the future, and you can kind of see the those stages of AI, let's say, but the dates aren't necessarily going to be what's shown. Those are just my guesses of the dates. So. Okay, and that's a quick view of the timeline of AI, where it's been, the AI winters, and some of its key developments. Okay, next we're going to be talking about what are some of the practical applications of AI/ML and how it's used, and some of the areas of where it's used. It's really the it will really pervade just about every aspect of our society eventually, and you can add smart in front of apps just about everything. Smart noun, smart toilet, smart refrigerator, smart mouse, smart everything. Eventually everything will be smart, and you will see pervasive applications throughout our society. So. Um, but this sort of ties first, before we really dive into that, first it ties into what are the key areas of AI that will allow it to really interact with us and our environment and our society. So machine vision, language processing, and robotics, those things that I mentioned before that we discovered were hard. Playing games, because it's a very finite rule system, turns out to be a very difficult problem, but not, really hard. So machine vision, which we thought was going to be relatively simple, turns out to be very difficult. But the modern AI and techniques of machine learning and deep learning has made great strides into uh, a machine that can see. So being able to recognize an image, being able to see and differentiate that there is something moving. That's a kid, kicking a ball running across the street. Motion analysis, scene reconstruction, the ability to identify that that is a, a tree, and that's a rock, and that's a boulder, and that's another car, and that's a truck. Image restoration, the ability to, when you have somebody that's hiding behind a rock, but you can partly see the person's head, the that person, there's a person behind that rock, right? The ability to restore an image, to be able to see that there are and recognize there are other atomic objects behind each other. Language processing, automatic speech recognition, natural language understanding, natural language operation, text to speech. So the ability to process language in many languages around the world. This is one of, we'll see later on, one of Google's projects. And the ability to understand people's that maybe in noisy environments or with accents is something that's not trivial. And then robotics, when you have AI, it will be very useful in a cylinder like Alexa, or as an advisor, or maybe just in our pockets as a smartphone. But eventually we'll have robotics that um, will need to be able to move around in our environment. And so there's different aspects that are important: the power source and management, sensing and perception, human to robot interaction, mobility and locomotion. So uh, you know, robots won't necessarily look humanoid when they interact with us. In my latest book, The Periodic Table of Ideas, there's a chapter on robotics, and there's lots of different forms of robots. It could be just as something as simple as a cube that moves around. But that can be, essentially it's Alexa on wheels, right? And that's much, or a Roomba. Think of Roomba as just a cylinder that moves around. That's a lot easier to get around than in our messy environment where you have dogs and cats and kids, than say, something with arms and legs, right? So okay, so some areas of applications we can think of in robotics are like factory automation, exoskeletons, again, human to machine partnership, autonomous vehicles. Think of a automated factory lift that can grab and move boxes and containers and things, such as things that are used in Amazon warehouses. Security systems, environment monitoring, remote exploration, and natural interfaces. So the ability to recognize speech, natural language understanding, eye and hand gestures, brain and computer interfaces, touch surfaces, and virtual reality. These would be really key also, we see, as we go into really into some of the more advanced 5G applications, where we have the evolution of the Internet of Things. And um, another aspect of 5G technologies is something called URLLC, Ultra Reliable Low Latency Communications, which really is the foundation for uh, being able to perform things on through wirelessly that were in 4G impossible. So the ability to, for example, drive a car with your smartphone, or to be able to control a robot arm with your smartphone. And you might think, well, that's crazy. I would never drive a car with my smartphone. But what if you were, say, a rescue worker or a first responder trying to control a robot into a fire, a raging fire to save somebody's life? Like that might be an application where you could use that sort of natural interface. You'd want to be able to have some good hand-eye gesture, some interface to be able to pick up a person or a dog and rescue into a fire, that kind of thing, right? So it's not necessarily obvious that you may not do that, but there are going to be lots of applications I think that will really be very interesting as we move into the 5G universe.
We
Cognitive
already
system, yeah, go ahead.
sorry, I was gonna say, we're already seeing some phones that have a lot of function, or not phones, cars have a lot of function via iPad.
Yeah, sure, and we'll see a lot more of that. I think the so one of the 1G wireless 1G was really characterized just trying to make really simple human to human telephone calls essentially. 2G was characterized by some really simple like text to texting, like a simple text to the replacement of like a beeper. 3G was and 4G were really characterized by machine to human interaction. And we see a lot of that. We're living in that now, right? Like downloading and videos and streaming news and that sort of thing. 5G will really be characterized by machine to machine interaction. So we really just at the start of that space now. At the start of 4G, pretty much everybody had their smartphone. They had one sort of quote unquote smart device, right? um, in 5G, it's anticipated you'll have about 10. The average person will have about roughly 10 devices when you have a smart car and a smart house and so forth, that you can all interact with. And we're starting to see the beginnings of that with things like your smart, like Ring, the smart doorbell, intelligent lighting systems and so forth. And we'll come to that in a couple of slides here. So, but yeah, we'll see a lot more of that, definitely. Cognitive systems, so smart agents and bots, expert systems, recommendation engines, adaptive learning systems, and translation systems. We have the beginnings of a lot of these now. When you go to Amazon and it recommends, oh, you bought this book and here's these other books that you might like, or you bought this movie and here's the other four movies that you may like, or you bought this toy and you might like those other toys. So those sorts of things are really an example of a cognitive system, right? So, um, so some areas where we'll see, and there's so many different ways you could, like I said, smart will infuse and transfuse and interweave itself through all every aspect of our lives eventually. But we can first start thinking about maybe movies and songs and audio visual applications, smart cities and public buses, smart home devices, Industry 4.0, social applications, and personal assistants as some early categories of ways to think about smart things. So some examples of smart home applications. I've given numerous talks on 5G, and this is a slide from one of my presentations. And so a uh, a smart home will certainly be an application for AI and early uh, cylinders of AI. In other words, non-robot like AI, things that are smart, but that aren't necessarily just a robot. Like so security monitoring, systems that are able to keep you safe, environment control, smart homes environment. When you leave, maybe it turns down the lights and the temperature and so forth, and entertainment. The ability to say, play your favorite songs or music you want to hear or interpret your questions and things like that. So just wherever you are, you just say computer and play this song. Communications and home phones, we already are pretty familiar, I think, with communications, the ability to access the internet remotely. Informatics like Echo and Alexa, profile execution, um, executes bend settings in the home, that kind of thing. Audio video things, play this movie, energy management. I'm going to be away for 2 days, and turn on the smart energy management mode. Safety management, helping keep your kids safe. Telecontrol. So one other simple example of the remote control stuff is not necessarily driving a car, but maybe something that like an arm you could control, or a simple robot you could control to say water your plants when you're away, that kind of thing. Appliance control, lock and access control. I want to temporarily let my friends into the home for 2 days, and that kind of thing. So they're already smart. Some of these exist already to some degree, like those digital locks that you can program through fingerprints and codes, and also remotely control from a distance or in another or online. But we'll see many, many more, I think, smart home applications in the coming decades. Smart city applications, so not just a smart home, but a smart city. I think we'll see more intelligent emergency services, intelligent power management, intelligent disaster recovery and public safety, public transportation, smart parking, augmented reality, the ability of, as you're going through a city, for you to have, say, a phone or glasses on, or your car can tell you, here you're passing this piece of history, or to tell you, here's the Statue of Liberty, and here's some of its history, and you're passing this landmark, and that sort of thing. Uh, the Internet of Things is, we're all very familiar with the Internet, but the Internet of Things is really a deeply connected devices all throughout society, right? So things talking to other things is really sort of characterizes the Internet of Things. So 5G is structured to support 1 million devices per square kilometer. And that works out, if you do the math like I have, that works out to one device per 0.92 square feet. So there'll be the 5G will be able to support a tremendous number of devices and things talking to each other. So the connected car service, sanitation management, transportation analytics, water management. So see here in this diagram some examples of smart intersections, that smart traffic lights. We've all been stuck at a dumb traffic light where there's literally no traffic around, but the light is red, right? Parking apps, drivers that will be able to divert them from crowded areas. So we see that with Waze, like the Waze app that can kind of redirect you to around traffic jams, bus stops that update users on live wait times, emergency departments that can receive alerts to accidents, trash cans that, intelligent waste management, smart street lights that turn on for passerby and monitor air quality, and solar panels that generate renewable energy to power technology in the city, are just some of the simple. There'll be many, many more to come with smart applications in a city. Industry 4.0. So the next generation of industry is called Industry 4.0. The first generation was mechanization and steam power, like a weaving and the loom. Industry 2.0, mass production, the assembly line, Ford Model T, electrical energy, that kind of thing. Industry 3.0, automation and computers and electronics is where we are today. And the next generation industry, characterized by cyber physical system, the Internet of Things, and advanced networks, and a lot of smart technologies that are incorporated into our industry and manufacturing. So safety monitoring, assembly line management, just-in-time management, ERP, cyber physical systems, the Internet of Things, the machine-to-machine communications, RFID controls, factory security, advanced robotics, PLCs, programmable logical controllers, and distributed control systems, management, manufacturing operations management execution systems, and supervisory control and data acquisition systems. So we'll see basically smart industry. Now you may not have as much interaction with smart industry because you might not be in that kind of arena. But I've seen lots, at Bell Labs, I've seen lots of really, really cool demos and stuff, and we had not just virtual, but kind of live demos as well. and it's pretty neat. So smart robots that can recognize when another robot breaks down and it automatically fixes it, or readjusting a factory floor to do something dynamically. It's we're just at the beginning of some really interesting advances in industry. Okay, and in this last section, we're going to explore a little bit about of who the players are, and maybe give you some examples of some key players and some of what they're doing. I think is really interesting. So there are lots and lots and lots of companies working in artificial intelligence, and some of the familiar names, of course, are also doing stuff in AI. Microsoft, IBM, Amazon, Salesforce, Apple, Facebook, Google are all doing very interesting things in AI, and just some of their projects, and we'll explore more of their projects in future slides here. Project Oxford and Microsoft, IBM's Deep Blue and Watson, Amazon's Alexa Voice and Echo, Amazon Machine Learning, Salesforce's Tempo and IQ, Apple's Siri and Perceptio, Emotion, Vocal IQ, Facebook's Deepface and Fair, Google's TensorFlow, Google Now, and Google Brain are just some examples. So it was a really neat lecture that I watched called AI at 22. It was a really interesting conference on what AI, or readout on what AI on the AI projects at Google. So I condensed that technical presentation down to just one slide here, so it really has some of the highlights, and you can follow some of those links, and maybe I'll show you some of those links in a second here. So, but AI for social good. So Google is focusing on like floods and fires and disaster recovery and health monitoring, trying to apply AI for social good, which is a really wonderful objective, right? AI for creativity. I mentioned before the partnership between humans and computers, and um, and to be able to empower a creative uh, a person whose job it is to have creative outputs, an artist, a musician, and that's a writer, and to be able to have AI partner with them is some of the objectives of AI for creativity. And then AI for language. We're all pretty familiar with Google Translate, the app. And if you go to the Google's website, they just type one language to another, and it has the the translation app. But they're adding and evolving that now. So I'm gonna head to a website here really quickly just to show you some. Hardy is a Google as a research arm of Google, that what it does is it takes language and translates it into an image. So composing an image just through real world knowledge. So show me an animal in Australia. So being able to contextually be aware that kangaroos are in Australia, and putting it in front of the Sydney Opera House. Fenaki makes movies sort of short movies from text. So, Funaki, create a photorealistic teddy bear that's swimming in the ocean in San Francisco, and it goes underwater and it keeps swimming under the water with colorful fishes, and then a panda bear is swimming underwater. So, generating this amazing little video, is just generated just from text, nothing but just some instructive text. So I think that's a really interesting one. Uh, a couple of very interesting things that are happening at Google. So okay, and here this in the in the lecture that I watched, they had a blue balloon that's stuck in the branches of a tree, and it moves and flies and stuff. And just from this text, it's able to create this interesting video. So that was a really interesting example. Microsoft is doing AI in 5 major areas. It's innovation sandbox, business scenarios, AI for society, autonomous systems, and security responsibility, and lots of different really interesting projects. AI just to do interesting, intelligent things, business applications, datamations for data visualization, a virtual stage, sketch to code to be able to help write code, AI for society. Angel Eyes, having AI help keep watch over your baby as it sleeps, detecting bacteria in water, a virtual museum visits, um, a pose tracker for position and orientation, autonomous systems like air drones, simulators, and intelligent robotics, machine teaching and machine reading, and enhanced security, synthetic data showcase, differential privacy, homomorphic encryption, and responsible conversational AI. For Amazon, they have excuse me, they have their AI projects broken down into 8 major areas, from computer vision, data extraction and analysis, language AI, customer experience, business metrics, code and DevOps, industrial AI, and healthcare. And they have cute names for their things. So like their computer vision projects, recognition, lookout, and panorama, data extraction, textract, comprehend, and A21, language AI, Lex, transcribe, and Poly, customer experience type applications, Kendra, personalize and translate, business metrics, forecast, fraud detector, lookout, DevOps, in other words, things that are used to help software developers develop software. DevOps Guru, Code Reviewer, and Profiler, Industrial AI Equipment Lookout, and Monitron, and Health Lake, and Comprehend Medical. Lots of really interesting uh, different applications for AI. You see as you see some more concrete examples of things that companies are doing, um, you can kind of see how AI is getting applied. But again, we come back to the big picture where we're using the ability to process data, and as we develop more intelligent learning systems and deep learning systems and the application of neural networks to train on data to learn without necessarily programming data is or program code uh, has lots and lots of interesting applications ranging from health and security and business to language, the uses of language. We see here how in some of those previous, in the first section of my talk, sort of generic constructs to more concrete applications. And then just a few other projects like AlphaGo and Google Photos and Translator, IBM Watson's newsfeed and spam filters, and IBM's Deep Blue and video game AIs and Panorama, Pandora Radio are some examples of artificial intelligence, machine learning, and deep learning. And here I just wanted to show in these last couple of slides in this section that there are lots and lots of companies that are playing in this space. More than I have time to go into, but just to really illustrate that really AI is not just driven by a few big companies, but there's a rich uh, ecosystem of companies that are all contributing in their own way or exploring different dimensions of AI. So, and companies involved in technology and enterprise intelligence and autonomous systems and Industry 4.0 and so forth. Okay. So just to wrap up, if I have to leave you with one slide, I think I would leave you with what were the really big key ideas. So this one slide I'll leave you with that summarizes really the key areas of artificial intelligence: predictive analytics, artificial intelligence are programs that can learn, reason, and make intelligent decisions. Machine learning, it's machines that can learn through experience without explicit programming. Neural networks are emulating human neurons that use connected software elements essentially to process data and learn and adjust their weights and learn from their past patterns and to use feedback, taking the output and feeding it back into as input. And deep learning, neural networks, artificial neural networks, ANNs and CNNs, convolutional neural networks that are able to adapt and learn and decide and cull information from big data. Okay, so thank you. That was that concludes my talk, and we'll open up for some questions here. So.
First, thank you, Ben. That was really interesting and a really good summary of both what AI is and where it's progressing to and kind of where we are now, which is really useful for the students as they start out this course.